Hi, in this video we are going to talk about the queue abstract data type, so let's get started. So basically a queue is an abstract data type, or in Java it is an interface. There are three basic operations for the queue. The enqueue, basically this is adding data to the queue abstract data type. We have the dequeue operation, removing items from the abstract data type, and we have the peek. Basically this peek is going to do the same as we have discussed for stacks, so it is like the dequeue, but here in the peek operation we are not going to remove the item, we're just going to get the value. Okay, so it has a FIFO structure, which means that first in, first out. The first item we insert will be the first item we take out. As you may recall, stacks has a LIFO structure. The last item we have inserted is going to be the first one we take out. Here, the first item we inserted will be the first we take out. It can be implemented with dynamic arrays as well as with linked lists. And it's very important when we implement the breadth-first search graph traversal algorithm. So let's see how it works in practice. We have the enqueue operation, we just simply add the new item to the end of the queue. It is a very simple operation, it can be done in order 1, so constant time complexity. So, we would like to enqueue the integer 10, so basically we just add it to the queue. We would like to enqueue 4, we just add it to the end of the queue. Okay, we would like to enqueue the 20, we just add it to the queue, and so on. What about the dequeue operation? We just simply remove the item starting at the beginning of the queue because it has a FIFO structure. So the first item we insert is going to be the first item we take out. Here, if we are going to call the dequeue method, it's going to get rid of the 10. Why? Because 10 is the first item we have inserted. Okay, so we have managed to get rid of 10. If we call the dequeue again, then we are going to remove the next item, so the 4. Okay, then we call the dequeue method again, then it's going to remove the last item. And it's very important that the peek operation is going to get the value of the node we have inserted first without removing the item from the queue. So in this case, the peek method is going to return 20, but it's not going to remove this item from the queue. So what about the applications? There are several applications for the queue abstract data type, for example in several graph algorithms. But for example, when a resource is shared with several consumers, we can represent it with the help of threads in programming, then we store them in a queue abstract data type. For example, CPU scheduling, or when data is transferred asynchronously, which means that data not necessarily received at same rate as it's being sent between two processes, for example, then we are going to store the data in a queue abstract data type. For example, in input-output buffers. And operational research applications or stochastic models relies heavily on queues. But it's very common to use these kinds of abstract data types, as we have seen for stacks, for example, that the stack memory relies heavily on the stack abstract data type. And the queue is very important as far as operating systems are concerned. For example, the Android operating system is going to maintain a queue in order to track the processes it has to make. But basically it is the same as we have discussed, that we have lots of tasks, and basically these tasks are going to be stored in a queue abstract data type to enable the operating system to make these tasks in sequential order. So for example, several smartphone applications are going to send tasks to the operating system. The operating system is going to store these processes or tasks in the queue abstract data type, and it's going to have a FIFO structure, of course. So we would like to process the first task that's being added to the queue, so the first in, first out principle is going to be valid. And of course the operating system is going to process these tasks on a one-by-one basis. So this queue is very important, as we have discussed for stacks as well. So basically these stacks and queues are the fundamental building blocks for most of the operating systems, for example. So that's all about the queue. Thanks for watching.